Designing Life from Scratch, a fledgling field is about to take off. Part 1. Technician James Horsfall. Left. And engineer Austin Shio work on a project at Twist Bioscience in San Francisco, California. On Friday, June 19, 2015. Twist receives emails from scientists seeking of a specific genetic sequence. Then they make the gene, using silicon engineering and chemical techniques, and mail it back. Mother Nature has always been life's master architect, working off genetic blueprints that are fine-tuned from one generation to the next. Until now, scientists increasingly are designing life from scratch, using inexpensive, fast and accurate tools to create and assemble strands of DNA like Tinker Toys and instructing cells to do things that nature never imagined. In industrial clusters in the Bay Area, La Jolla and Boston, the competitive gene-building field is doing for biology what Johannes Gutenberg did for printing, turning what was once a laborious and uneven artisan effort into affordable and accurate mass production, with the potential to create an industry that could lead to products worth hundreds of billions of dollars. The fast-moving field is not only prompting investor funding but also sparking calls for oversight. The goal is to build improved medicines, better biofuels and new chemicals, and perhaps someday splice new genes into sick people, fixing inherited diseases. But the cutting-edge technique also could be used to build dangerous pathogens for warfare. We're accelerating genetics, said biochemist Emily Leproust, co-founder and CEO of Twist Bioscience, a 2-year-old San Francisco company with $82 million in venture capital funding. The firm aims to use new silicon chip-based gene-building tools to build DNA 100 times more efficiently than existing methods. The longer and less expensive the DNA you can make, the more complex the outcome can be, she said. Advertisement. The advancements in gene synthesis create both exciting and alarming possibilities, said Eleanor Pauwels, a scholar with the Washington, D.C.-based Woodrow Wilson Center's Synthetic Biology Project, created to foster informed public policy regarding the fledgling field. For instance, she said, gene building could create personalized therapies, say, for example, a tailor-made virus that attacks specific cancers. But it also could manufacture dangerous germs or microbes that don't exist in nature. She added, today, the smallpox virus is safely locked up in a high-security lab. But what if an unscrupulous laboratory obtains its genetic sequence and sends a vial of the genetic material to anyone who will pay for it? This growing ability to engineer life at the molecular level carries with it the risk of allowing for the development of new biological weapons. Pauwels said, gene synthesis is possible because of this simple fact: life is just code. 4 molecules, each called a base, the most irreducible unit of life, represented by the letters A, adenine, T, thymine, G, guanine, and C, cytosine. Write the words for the Dictionary of Creation.